In this video, we will practice identifying similar triangles and applying properties of similar triangles to solve problems. First, let's review the theorems that we have to prove that triangles are similar. The three theorems we have are angle-angle similarity, side-side-side similarity, and side-angle-side similarity. And like we had in congruent figures, we shorten angle-angle similarity to AA with the squiggle to mean similar. Side-side-side is SSS with the squiggle, and side-angle-side is SAS with the squiggle. Also, remember that when we want to show that something is similar, we want to show that the angles are congruent and that the sides are proportional, meaning that they are in the same ratio. So for our first example, we have to determine if the triangles are similar. Now, based on what we have, we can see that we're probably going to try to use side angle side because we have this given side of angle G and angle J is congruent. Additionally, now I need to compare the side lengths to make sure that they are proportional. So the smallest of the given sides in the top triangle is 45, and the smallest of the given sides in the bottom triangle is 99. So one proportion is 45 over 99. The next one, the larger of the given sides in the top triangle, is 60, and the larger of the given sides in the bottom triangle is 132. So my second proportion is 60 over 132. Now if I simplify my fractions, the 45 over 99 becomes 5 over 11, and the 60 divided by 132 becomes 5 over 11. So because of the fact that we have these proportions are the same as 5 over 11, and I have the angle congruent, we can say that the triangles are similar by side angle side similarity. Now the next thing we need to do is complete the congruent statement. What we can see is the first vertex, J, is where the angle that's given. So the given angle in the top triangle is G. So my statement is going to start as triangle G. And then my next vertex is this K, which we can see is the end of the small side. And the end of the small side in the other triangle is F. So it'll be JF. And then my last remaining vertex in the bottom triangle was L. And in the top triangle is E. So my statement is triangle JKL is similar to triangle GFE. For this example, we can see that we are probably going to try to use side, side, side because we have three sides in both triangles. So let's compare the sides. Now the smallest side in both triangles is the 6 and the 42. So I'm going to write a proportion of 6 over 42. Then my medium side in the top triangle is 8 and the bottom triangle is 56. So I can say that a proportion would be 8 over 56. And the largest side in the top triangle is 12, and the largest side in the bottom triangle is 84. So I can set up 12 over 84. Now when I simplify these ratios, 6 over 42 becomes 1 over 7. 8 over 56 becomes 1 over 7. And 12 over 84 becomes 1 over 7 as well. Because all of these are the exact same, we can say that the triangles are similar by side, 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 similarity. Then I need to complete the congruent statement. So first, I need the vertex K, which in the bottom triangle is between the medium and the large side. So the angle between the medium and the large side in the top triangle is A. So I'm first going to have triangle A. Then I need my next vertex is L, and L is between the medium and the large side, or the medium and the small side. So the angle between the medium and the small side in the top triangle is B. So I'll have B, and then my last remaining vertex, which we're going to fill in, is M, which is between the small and the large. So between the small and the large in the top one is C. So it'll be triangle ABC. For the next example, we are given two angles. Now, because both of these angles are 37, we know that they are congruent, and both of these angles have the box, which means that they are both 90, so they are congruent. So we can already say that the triangles are similar by angle, angle, because we don't have to compare the sides at all. For the next part, we have to match up our vertices. So I first have triangle F, and we can see F is the 37-degree angle. So the 37-degree angle in the bottom triangle is V. Then I have E, which is the right angle in the top triangle. So the right angle in the bottom triangle is U. And then my last remaining vertex is the one that's an unlabeled angle. So in the top triangle it's D, and in the bottom triangle it would be T. So it's triangle VUT. For the next example, we can see that while it's not marked, both of these angles are 63. So we have a congruent angle that's given to us. Then I also could see that I'm probably going to use side angle side because I have the two sides around that angle are given, but I'm going to check them to make sure they're proportional. So the smaller side of the top triangle is 16, and the smaller side of the bottom triangle is 9. So the small side to the small side is 16 over 9. And then the larger side of the top triangle is 25, and the larger side of the bottom triangle is 12. So this is my large to my large as my proportion. Now, if I want to simplify these, 16 over 9 doesn't simplify, as well as 25 over 12 doesn't simplify either. So these are my two ratios. Because they are not the same, this means that the figures are not similar. And because the triangles are not similar, we don't have to complete the similarity statement, so you could just fill in NA for not applicable. In our next example, we can see that the triangles have this given pair of angles marked as congruent. Now, while I don't have any other angles congruent, based on our previous knowledge of vertical angles, we can mark that this angle is congruent to that angle. So because of this, we have two angles that are congruent, so we can already say that the triangles are similar by angle, angle. Then we're going to match up our vertices. So the first vertex for my similarity statement is P, and I can see that P is that angle with the vertical angle, and it's the same angle in both triangles. So I can fill in triangle P. Then I need the angle Q, which Q is the double marked angle. It's the double marked angle in the other triangle is G. And then lastly, I need the vertex that corresponds with R, and we can see that R is the unmarked angle. So the unmarked angle in the other triangle is H. So it's similar to triangle PGH. Now we're going to practice solving to see that each pair of sides are similar. Now we have to set this up and we need to kind of see which sides are corresponding. And you can use this statement that's given to help you if needed. So the first side length I have is this side NM, and based on the location in the statement, we can see that NM corresponds to DE. We also can identify that we have CM is the other side, and we can see that since CM is the first two letters in the statement is CD. Now I can use this to set up a proportion. So I could say that 8 over, and instead of calling this a question mark, I'm going to make this an X. So 8 over X is equal to 6 over 30. Now to solve, I would solve like you normally would any other proportion. So I would cross multiply, so you'd have 6x is equal to 8 times 30, and when I simplify, I'll get 6x equals 240, and divide both sides by 6 to get x is equal to 40 as your final answer. In the next example, we're again going to start by identifying our corresponding sides. So I first have the side length of AK, and I can see that AK is the first two letters in the statement. So the first two letters in the other statement is AB. So AK corresponds to AB, as well as the other side I'm given is AL. We can see that AL is the first and the last letter in the statement. So the first and the last letter in the other statement is AC. So the 15 corresponds to the missing side. So I could set up my proportion. So I have 20 over 28 is equal to the 15 over, and again, instead of calling this a question mark, I'm going to call it an X. So now I'm going to cross multiply to solve. So when I do that, I get 20x, 28 times 15, and if we simplify, we get 20x equals 28 times 15 is 420, and then if I divide both sides by 20, I get that x is equal to 21 as your final answer. For the next example, I'm going to follow the same process, but I'm going to also have to solve for x. So my first side length I'm given is UK, and we can see that this UK, since it's the first two letters in the second statement, it corresponds to UV. And UV has a length of 56. Then the side length JU is the first and the last letter of the statement, and the first and the last letter of the other statement is UW. So it gives us 28. Now when I set up my proportion, I can say x plus 1 over 56 is equal to 7 over 28. And now we're going to solve for x like we did in the previous problems. So in order to do so, I would cross multiply. So I'd have 28 times the whole value of x plus 1 is equal to 7 times 56. So when I solve, I would distribute the 28. So you'd have 28x plus 28 is equal to, and 7 times 56 is 392. If I continue to solve, I subtract 28 from both sides, give you 28x is 364, and divide both sides by 28 to get x is equal to 13. In our next example, we can see that the triangles are overlapping. We have a smaller triangle, triangle QBC, and a larger triangle, triangle QRS. Now we can match up the parts of this triangle by using our corresponding sides. So if we first use the smaller side length of QB, is going to correspond to the full side length of QR. For the other part, I have the smaller side length of QC, which is 27, corresponds to the full side length of 99. So when I set my proportion, I have the smaller side of 24 over 12x minus 8 equal to the smaller side of 27 over 99. Now to solve, I'm going to cross multiply. So I'll have 99 times 24 is equal to the 27 times 12x minus 8. Now to solve, I'll distribute my 27 and multiply the 24 and 99. So 24 times 99 gives you 2,376. 27 times 12 gives you 324. X minus 27 times 8 is 216. Now to solve, I would add 216 to both sides, so 2,376 plus 216 gives you a value of 2,592 equals 324x, and then divide both sides by 324 to get 8 is equal to x. For the next example, I'm again going to start by identifying my corresponding sides. So I'm given the side length of 26, and the first triangle is UW, and UW is the first and the last letter. So the first and the last letter in the second triangle is LN. So that corresponds to LN, which is 13. Then I also have UV, which is the first two letters. So the first two letters of the next theorem, or the next statement, is LM. So the 14 corresponds to the x minus 7. Now if I set up my proportion, I have 26 over 13 is equal to 14 over x minus 7. Now I cross multiply like we have in the past. So I have 26 times x minus 7 is equal to the 13 times 14. So if I distribute my 26, I get 26x minus 26 times 7 is minus 182 is equal to, and 13 times 14 is 182. So when I add 182 to both sides, I get 26x equals 364, and divide by 26 to get x is equal to 14. For the next example, we're going to solve for x, but we're going to start to implement real-world examples with it. So, and we're given additional sides we don't necessarily need, but we have to just make sure we pick out ones that correspond. So based on what is given, we can see that this side length of 8 is across from the angle, and that also corresponds to the side length of x. Okay. Now, when I want to pick out another side, I have to be careful. Let's say I decide to pick out the side length of 4. We can see that this side length of 4 is the smallest side of that whole triangle. Now, the smaller side of the second triangle is 6. So that means the 4 is going to correspond to the 6. So if I want to set up my proportion, I could say 8 over x is equal to 4 over 6. Now the other alternative you could use is, instead, if you chose to use the 6 as your other side, we see that 6 is the medium side of this figure, and the medium side of the other triangle is going to be that 9. So this would give you a value of 9. So if I set up that proportion, I still need the 8 over x, and it's going to be equal to 6 over 9. Now, whichever way you choose to solve, it's going to give you the same answer of 12. And because this is a real-world application problem, we want to add in our units of meters. In the next example, we can see that we first need to determine the side length of the big triangle, which is labeled as x, and that corresponds to the side length of 110. I also have this other side length. Now, of the small triangle, this is the side we're given, is 90. However, for the big triangle, we're really talking about this whole side length. And we know from combining the 90 and the 90, this side length is 90 plus 90, which equals 180 yards. So now if I want to set up my proportion, I'm going to use the 110 to the x, so 110 over x is equal to the side length of the small triangle of 90 over the whole side of the big triangle, which is 180. Now I'm going to solve like I would any other problem. So you would cross multiply. So you'd have 110 times 180 equals 90x. Now when I solve, you get 110 times 180 gives you a value of 19,800 equals 90x. So you would divide both sides by 90 and solve to get that x is equal to 220. And again, because this is a real-world application problem, we're going to include our unit of yards. Now in our next example, I can identify my corresponding sides. So I have that the 15 corresponds to the 5. And we also have that the giraffe's height of x corresponds to the person's height, which is 5 feet 3 inches. Now the issue is we are using feet and inches. We want to convert it either to all inches or all feet. Because we are typically more comfortable working in inches, I'm going to change everything to inches. So 5 feet 3 inches becomes, and we know that 1 foot equals 12 inches. So it would be 5 times 12 plus 3, which gives you 63 inches. For my other sides, I have 5 feet, and that becomes 5 times 12, which is 60 inches. And then lastly, I have 15 feet. That's 15 times 12, which we know becomes 180 inches. So now I can set up my proportion. So I'd have 63 over x is equal to 60 over 180. Now when I cross multiply, I'll have 63 times 180, which gives you a value of 11,340, and 60 times x, which gives you a value of 60x. And when I divide both sides by x, or by 60, to get x, I get that my answer is 189. So this means your answer is 189 inches. Now if I wanted to change this to feet, what I could say is I could take the 189 inches and divide it by the 12 inches per foot, and that gives you 15.75 feet. And we know that 0.75 times 12 means that I get 9 So my answer, if I were to write it in feet and inches, would be the 15 feet, and the remaining 0.75 is changed to the 9 inches. So it would be or 15 feet, 9 inches as our final answer. And either form is fine. It may depend though on the question. For our last example we have here, we're going to match our corresponding sides. So my side length of x corresponds to my side length of 15. Additionally, my side length of 120 corresponds to my side length of 20. So I could set up my proportion as being x over 15 is equal to 120 over 20. Then if I want to solve, I would cross multiply. So you'll have 20x is equal to 15 times 120, which gives us a value of 1,800. When I divide both sides by 20 to solve for x, you get x is equal to 90. And your units are feet, so the answer is 90 feet.